Hi all, I am here with my new video on solutions and their properties. Let's start. In this video, we will learn about effect and behavior of solute in the solution. When a solute dissolves in a solvent, the particles of the solute bond with the particles of the solvent, causing the vapor pressure of the solution to be lower than the vapor pressure of the pure solvent at the same temperature. The effect of this vapor pressure lowering is to raise or elevate boiling point of the solution and lower or depress the freezing point of the solution in comparison to the boiling and freezing points of the pure solvent. Example, when 1 mole of glucose is dissolved in 1 kilogram of water, the boiling point of the solution is 100.52 degrees Celsius and the freezing point is minus 1.86 degrees Celsius. In contrast, the boiling point and freezing points of water are 100 degrees Celsius and 0 degrees Celsius. Colligative property. Properties that depends on the number of solute particles present and the nature of the solvents do not depend on the actual identity of the solute. For example, if we replace 1 mole of glucose with 1 mole of urea, the results would be exactly the same. Example of colligative properties are freezing points, depression, and boiling point elevation. Behavior of electrolytes in solution. Electrolytes produce ions when they dissolve in the solution. These ions are free to move in solution, so the solution conducts electricity. The greater the concentration of ions, the greater the conductivity of the solution. Ions can be produced in solution in either of two ways. When ionic substance such as NaCl dissolves in water, the water separates the ions present in the NaCl crystal lattice. This process is called dissociation. It is represented as below. When a polar covalent substances such as HCl dissolves in water, ions are created by the interaction between HCl and H2O molecules. This process is known as ionization. It is represented as below. When the boiling point and freezing point of solution of electrolytes are examined, it's found that they don't obey the simple relationship del T is equal to K multiplied by M. The boiling points are higher and the freezing points lower than expected. The reason of this abnormal behavior lies in the fact that each mole of dissolved electrolyte produces more than 1 mole of particles. For example, in very dilute aqueous solution, 1 mole of NaNO3 produces 1 mole of Na plus and 1 mole of NO3 minus. Therefore, the boiling point elevation and freezing point depression are twice those for a molecular substance. We need to specify that a solution of an electrolyte must be dilute because a phenomenon known as ion pairing lowers the number of dissolved particles present in more concentrated solutions. As a result of ion pairing, the effect that an electrolyte has on raising the boiling point and lowering the freezing point of a more concentrated solution is less than we can predict for a dilute solution. In many laboratories, solutions are prepared as a concentrated stock solutions. In order to use a working solution in an experiment, it is necessary to know how to dilute the stock correctly. The formula to prepare a working solution from a stock solution is as following. M stock solution multiplied by V stock solution is equal to M working solution is multiplied by V working solution. Mole fraction formula. Suppose a solution contains two components A and B. The mole fraction of component A is denoted as XA and is defined as below. XA is equal to moles of A divided by total number of moles. Na divided by Na plus Nb, where N represents the number of moles of each component. Calculating the freezing and boiling points of solutions. If a solute is molecular, not ionic, and is non-volatile, then the changes in the boiling points and freezing points of a solution bear a simple relationship to the molality of the solution. Del Tb is equal to del plus Kb multiplied by M. Del Tf is equal to minus Kf multiplied by M, where del Tb and del Tf refers to the change in boiling points and freezing points. The plus and minus sign indicates that the boiling point of a solution is elevated and the freezing point of a solution is lowered. Kb and Kf are known as the boiling point and freezing point constants, and they depend on the solvent that is used. The unit of these constants are degrees Celsius per mole. The Kb and Kf represents the number of degree that the boiling point of a solvent is raised or its freezing point is lowered when 1 mole of a molecular non-volatile solute is dissolved in 1 kilogram of the solvent. Coming up next, part 4, types of homogeneous mixtures. To watch new videos, please subscribe and like.